hostel, every student, they decide that I will go to that canteen which is closest to my hostel. Then if this is the criteria, and then if we plot the area of the area from, or area of the hostel from which the student will go to the particular canteen, then that is like your Thiessen polygon. Okay, so that means each hostel will go to only one canteen, and which canteen it will go, which is the closest by distance, walking distance, which is the closest, in that canteen they will go. Then at a particular canteen from which what are the hostel from which the student will go to that canteen, that area is nothing but, here is the Thiessen polygon. Okay, so it actually tells that which are the area, which are the point is closest to this station compared to the other station. Okay, so here in this figure I can tell that this line, okay, this point is actually closest to the station A than station B. Okay, so if you draw a line, straight line distance here from here to station A, and here also from here to station B, the distance to station A will be minimum. Okay, so like this way, if you take this point, and if you draw a line to C point, and if you draw a line to A, and if you draw a line to B, you will see that the distance to C is the lowest. That is why these points have been assigned to station C. Okay, so like this way, each and every point of the catchment, if we assigned to that principle, that whichever station will be the closest, we will assign that point to that station. Okay,
so but how do we set these stations?
Yes, the station is set, but by means whatever we have practically. Means we know that where are the rain gauge stations. In Calcutta, there are 3-4 rain gauge stations, or in our campus also one rain gauge stations we are installing. Okay, so rain gauge stations we are means when we will do the Thiessen polygon, before that we know the fixed position of the rain gauge station, because that is what the means we have installed previously.
Sir?
Yes.
Sir, in this figure, we were interested in the catchment area, sir. Then why we have installed, sir, station D outside the catchment area, sir? We must have installed it inside it.
Yes,
because we are interested in catchment area only.
But it is not the only one catchment we have. Okay, we have another catchment also here. Okay, out just beside this main catchment, this area is also one catchment, and this left side is also one catchment. If we see about the bigger picture, each and every area is inside the catchment. Now, in this case, we are concerned about this catchment only, but this station D is also inside another catchment. Okay, and maybe when we will calculate the mean value of that catchment, that time maybe we can consider station B, which may be inside this catchment. But I hope that station B is also outside, is not it? No, station B is inside. Okay, so suppose when we'll calculate, okay, let me draw another catchment. So suppose maybe another catchment, it is like this. Another catchment is here. Okay, and the outlet of the another catchment is here. So this station D is actually inside of this catchment. Is it clear?
Yes, sir.
Stations, rain gauge stations are fixed. Okay. And if you ask that why, how we have fixed it, we have fixed it based on our opportunity and based on our convenience. Suppose we are fixing that at the top roof of our 8th floor building, we will install a rain gauge station. Okay, automatic weather station. How we are fixing? Because we have the certain this location and the roof is free. This is a educational institute, so we are making a rain gauge station there. Okay, we cannot install rain gauge station means at any place. So like this way we are fixing the rain gauge station where we will fix. But there is some formula, I think you have know that each 10 square kilometer area there should be at least one rain gauge stations, isn't it? That certain conditions are there. So rain gauge stations are fixed previously. After it is fixed, means it is there, then catchment delineation is separate. I delineate the catchment. Then I see within my catchment what are the rain gauge station I have. Then I see that, okay, within my catchment I have A, B, C, E, but D station are outside the catchment, but I feel that this rainfall in this area may be similar to station D. So that is why I also take consideration of station D also for calculation of average of this catchment. Is it clear now?
Yes, sir.
Okay. So that is why we are also considering the station D, which may be outside my catchment. So after this, so I have delineated my catchment. I have got where inside or just outside my catchment, what are the different rain gauge stations are there and what is the rainfall value, okay, of that station. Now I will do the draw the Thiessen polygon. My criteria is the area which will separate. Within that area, each and every point will be the closest to the station. Okay. So within this blue area, each and every point, this point is also should be closer to station B. So if we draw a point here, distance to station B, here station C, and here station A, this point will be the closest. Okay. Here, I can draw it just to make it clear. So from this point, suppose from up to station C, I draw a line. Okay. Now I draw another line from here to station B. Okay. Station B is here like this. If you see the picture. And if I draw a line here from here to station A, which one is the shortest? The distance to station B. That is why this point have been assigned as a influencing area of station B. Okay. So is it clear the philosophy behind formation of Thiessen polygon?
Yes, sir.
Okay.
Yes, sir.
Now how mathematically we do it? Okay, that is now we need to know. So mathematically we use the formula method of Delaunay triangulation. Okay, and then mathematically all this area we called Voronoi diagram. Okay, so taking creating the Voronoi diagram is my aim. So for Voronoi diagram, creating the Voronoi diagram, the first step is Delaunay triangulation. What is that type of triangulation? We will join the station, rain gauge station, in a triangular manner. In survey also, whatever you have done, you've done the triangulation, is not it? So the individual station here, like this way, station A, B, C, D, E, we will join the station in the form of a triangles. It is my first step, but there should be certain condition to be fulfilled. The condition is, if there is more option to join the stations in a triangle, then I will choose the option where the minimum angle is maximum, or the triangles looks like the more or like equatorial triangle, or one of the angle should not be very low. Okay, so one example I can see here, if you see these stations, I have divided into triangulation like this way. But if you can just give an thing, I could have made different way also. Where is anything? Okay, I could have done this triangulation different way, is not it? I could have joined from this station to this station, is not it? Then I could have joined this station to this station. Okay, then I could have joined this station to this station. This also I will get a triangle shape, but this is not a Delaunay triangulation, because here the angle is very acute, is not it? Angle is very small. So I don't want, I want that all the three angles will be as big as possible, and the triangle looks like as much as possible equatorial triangle. And if I have option, then I will choose the most angle one. Suppose it can be shown here that these 4 stations are there. Okay, let us delete now all these lines. Suppose station B, C, D, E we have. So which way, different way we can join all these stations to form a triangle? One way is like this. Okay, we can join this station. We can join this way. This is a triangle. Then we can join this to this. We can join this to this. This is a one type of triangulation. But another option is also there. That option is I can join these two, is not it? Suppose I delete now this one. This also, joining these two also will separate. But here, if you see these two angle, okay, these two angle, one of the smallest angle will be lesser than if we join these two. Okay, so these two angle you can obviously see, or this angle are more than this angle. Okay, any of them means lowest of these 3 angle will be higher than the lowest of these 3 angle. Okay, so that is the thing we have to keep in mind. My triangulation should be, the angle should be as greater as possible. That is the one of the thing. Another thing is that there, that is means complex to understand. we should be able to draw at least one circle such a way that this circle will not contain any other station. Okay, but I am not explaining that because without that also, if we only simply follow this triangulation, that the triangle should look as equatorial as possible, because if you see this triangle, two triangle is looking as means good, it is not that thing. But if I do this, okay, if you see this triangle is becoming long, okay, but this triangle is looking good, but this is not looking good. Okay, not looking good means angles are small. Okay, so our first step is to this Delaunay triangulation. So examples, another examples are given here. So, but in this case, the Delaunay triangulation is given here in the red dot. Okay. So after we do the Delaunay triangulation, if you see, when I join this station, that means this is the shortest distance. Straight line is the shortest distance between two stations. Okay. Now what I will do, I will draw a perpendicular bisector. I will draw a perpendicular bisector along this line. So what is perpendicular bisector? Maybe this angle is not 90 degree, but you take it that way. It is. So perpendicular bisector is, it is bisecting the whole line into two equal parts. This distance and this distance is same. And again, it is perpendicular means it is the shortest distance along this line, this way and this way. So when we tell the perpendicular distance, that we know that all area in the left side should be closer to station A. Is not it? Because this is the middle point here. So all the point left side of this point will be closer to station A. And all the point right side of this line will be closer to station B. So this perpendicular bisector is actually differentiating in distance, that which area in by distance will be closer to station A compared to station B. Okay, like this way, if we draw a perpendicular bisector here in this line A and C, okay, if we draw a perpendicular bisector between A and C, again my line is not perpendicular bisector, I request you to adjust. So if this is the perpendicular bisector, actually I have to move to some extent here. Okay, if it is this perpendicular bisector here, then of course it is telling me that left side of this line, okay, make it color different. Okay, left side of this line will be closer to station A and this line will be closer to station C. Whereas this line is telling which is station B and C. So I can get a point here. So in this area, this blue and black, it will be obviously it will be closer to station C, because it is blue line is telling me it is closer to station A compared to station B, but green line is telling me this point is closer to station C compared to station A. So ultimately it is closest to station C. Okay, so like this way the, so you can see here, we'll join all the perpendicular bisector and we'll let the perpendicular bisector to cut each other. Okay. Then we can easily divide the area, because I know this point will be closer to station C, because it is the left side of this perpendicular bisector and it is also this side. Okay. So because this side is telling me it is closer to station C compared to station A, and obviously if we draw that, it will be means closer to station C. Okay, so like this way, the meeting point of all the perpendicular bisector, if we join that, all the meeting point will join that, and outside will be the catchment boundary, because these two perpendicular bisector may not join, then outside will be the catchment boundary itself. So then I will easily can divide the whole area, which will be the closest to my stations. Okay, so then obviously I can calculate this area by planimeter, or like in this way it have been shown in the graph paper. Okay, so you can calculate the area, and that will give me the A1, A2, A3, A4, A5. Total area you have already calculated by planimeter or graphical procedure. Then your weightage factor of station A will be area of the red divided by total area. Okay, so that is the procedure, and you get the weighted area, weighted factor, and then you use the formula pi into weightage factor. Okay, and sum it up, you will get your average precipitation by Thiessen polygon method. So in a gist, what is the procedure? I have to join my station in a triangular way, and I have to choose the triangle such a way that the minimum angle of the triangle will be maximum. Okay, around different option, and the triangle will look like, means no angle of the triangle will be very small. It should be as big as possible. Okay, so like this way we made the triangle. Then at each side of the triangle we'll draw the perpendicular bisector, and then we let the perpendicular bisector to join each other. If three perpendicular bisector join in a single point, it is okay. Otherwise we will be joining two, and then we can join these two separately in a line. Okay, then automatically area will be divided. Thiessen polygons will be created. Now I think you know from your 10+2 or class 10 mathematics how you can do by geometry, how you can do the perpendicular by manually. You need the compass, is not it? So you will put a compass there. You will take a arc more than, you will take a arc more than the half distance, and you will do arc both side, draw arc both side, and from here also you will draw the same length arc on the both side. It will cut two directions, and the cutting point, if you join, this will give you the Thiessen polygon. I cannot show it because I don't know how I will put a compass here, but I will show you a video. Okay. So that is the way I can do the perpendicular bisector. So any questions? So I think you can do it by manually. So I will supply. I think this week only I will supply the catchment and the rain gauge station Thiessen polygon. So you have to do it by hand and scan it, and you have to submit. Okay. So If the questions are not there, then we move to the next method, that is the isoheital method. Now, Dev, Anand, can you tell that what is the actually assumption in our this Thiessen polygon?
So one thing is rain uniformly happen in the catchment.
One thing is that rain.
So rain will precipitate uniformly in the catchment.
You are telling completely opposite. Our assumption is that rain is not uniform. That is what we are calculating the average. And it can obviously means you can see that rain is not uniform because station A is 0.55, station B is different. Okay. So assumption is that station rainfall is not uniform. Okay. Then another assumption. Anyone, that means we already explained by your hostel and canteen, all this example, that which assumption, based on which assumption we delineate the different Thiessen polygons.
Sir, all the points in for a given station have equal, equal rainfall.
Yes, that is one assumption. I will admit that in the same influence area, all the point inside that will have same rainfall. Okay, but how we divide the area based on anybody?
The nearest distance of the point from the station.
Very good, very good. So that is what our assumption is in the Thiessen polygon method, based on distance only. Whereas here your arithmetic mean, it is same, means influence is same. So distance only, based on distance only, I am separating the area. Whereas Kobita is also right that our another assumption is that inside the red area, our rainfall is same, which is 0.55. Okay. Now that is the shortcoming, not means which is the shortcoming, that based on the distance, I am separating the area. Because whether rainfall or cloud, does it means anyway means care about the distance? Whether rain falls means measuring the distance. Okay, within this area I will fall this, within that area I will fall that. Rain does not occur this way, is not it? That means the rainfall is not distributed in perfectly distance manner. It can be distributed anyway. Okay, so that shortcoming, we improve it by isoheital method. Okay, here also we divide. Here also we divide the influencing area, but that division is not based on distance. That division is based on our rainfall data, rainfall values. Okay, so based on the isoheights. Okay, so in this area, the rainfall area division is this one. Inside these two isoheight, the rainfall will be same. Inside these two isoheight, rainfall will be same. That is our assumption again. Because inside this area, rainfall may not be same, which is means may not be now, which will not be same. Means we are 100% wrong in our assumption, but we have to assume. Otherwise, you tell me the solution. Okay, there is no other solution other than this assumption. And in science, everywhere the assumption is there, because the point itself, okay, this I tell everything because every batch, because this is very easy to understand. The point itself is an assumption. What is the definition of a point? Point have no dimension. Okay. But can you then draw a point practically? How I can draw a something which have no dimension? When I am drawing this point, it should have some dimension. Otherwise, how I can show it? So the basic mathematics is like this, complex, wrong. Then I can tell, okay, then point is wrong. No, because without that we cannot progress. What is the definition of straight line? Straight line should not have any width. But how we can, it is the line joining 2 points, it should not have any width. But how we can draw a straight line without any width? It have only one dimension, length. It don't have any dimension of width. So it is not possible. It is our assumption. Okay. So like this way, we are also assuming that the rainfall inside this 2 isoheight or rainfall within this area will be uniform. So that means in isoheital method also we'll divide the area based on its influence, but it will be based on isoheight. So what is the isoheight? Okay. So isoheight definition is, it is a line joining points of equal rainfall magnitude. Okay. So that means, suppose here is an example of isoheight. This line, if it is a isoheight and it is written 6, it is like a contour line. Okay. In contour line is a line joining of same elevation. Like this isoheight is a line joining the same rainfall. Along this line, everywhere the precipitation is 6. Along this line, everywhere the precipitation is 4, 8. Okay. So if we have the isoheight, I know that this line have rainfall have 8. So outside this line, rainfall will be different. And if this line have rainfall of 6, so in between, the rainfall will be in between 6 and 8. Okay. So then I take the average of these 2 isoheight as the average rainfall within this area. So in isoheital method, we have to draw the isoheight at first. Okay, then we have to measure the area between 2 isoheight. Then average rainfall is area into average of the 2 isoheight, because this is 6 and this is 8. So average is 6 plus 8 by 2, 7. Okay, that is P1 by P2 by 2 into area between these two. Okay, so A1 into P1 by P2 by 2 plus, suppose this is your A2 area, into 10 plus 8 by 2. Okay, P3 plus P2 by 2. So like this way you do it and divide it by total area. That will, so in this way the division is not based on distance. The division based on actual rainfall. Okay. But what we need to do now? Here,
Sir,
yes.
but in reality, this method is not possible because we have a limited number of stations, sir. Then how we will find the isoheights?
Yes, that is the thing that you are. But in reality, we can make it to some extent possible. Error will be there, but that is the shortcoming of this method. Okay, you have rightly told the shortcoming. But suppose if we have a good number of stations, then it can be useful, isn't it? Or somehow
Yes,
if
sir.
you have given the isoheight, you already know the isoheight. By some other method, you have calculated the isoheight. Then it will be useful, isn't it? If I have the isoheight, or if I have good number of rain gauge station, so that I can have the isoheights, then it is a good. Otherwise, shortcomings are there. If this is the 5 number of station, then I can calculate the ISO height. It may not be accurate. Okay. Now, then our next step is, in this example, 5 station, or in this example, there are more than 5 station. So in this example, how I will draw the ISO height if it is not given. Okay, so let us delete all this line because I showed in the previous section. Okay. So now in this example, I have this catchment. I have this rain gauge station, black dot, 7, 9.2, 12, 7.2, 4, 9.1. Now using this rain gauge station value, I need to draw the ISO height of this area. Okay, so let us think that the inter ISO height distance will be 2 mm. Okay, that means it will be 4, 6, 8, 10. So if you make it more closer, your result will be good. Suppose 6, 7, 8, 9, 10 means the interval is 1, it will give good result. But here it have been shown ISO height interval as 2 mm. Okay. So using here, let us try to draw the 10 mm ISO height from this figure. So how we can draw it? See, understand this. Here we have measured the rainfall. Okay, 9. C station, I have measured the rainfall 9.2. D station, I have measured the rainfall 12. E station, I have measured the rainfall 9.1. A station 7.2. B station 7. F station 4. So if we assume, again it is my assumption, if we assume that this from point to C to D, the rainfall is linearly varying. So point D's rainfall is 12. So as we move toward the point C, rainfall will reduce from 12 to it will come 11, 10. Then at point C, it will be 9.2. So if we suppose join these 2 stations C and D, so along this line rainfall is varying from 12 to 9.2. So that means somewhere there must be 10, is not it? If it is 12 here, if it is 9.2, and again I am assuming that the variation will be linear, so at some point it should be 10. So where is that 10? That I get it. Okay, so here this is the 10. I mark it. This is 10. So like this way, I can join this station B to station D. Is not it? Here it is 12, here it is 7. So obviously rainfall should reduce if rain is happening means non-uniformly but everywhere. Okay. So it should come from 12 to 7. So it should change the value. So somewhere in between there should be 10. So I mark the 10. How I will mark it? I see 12 to 7. So variation is 5. Then I give a scale and I see what is the distance. Distance may be 10. Distance may be 5 inch. It may be 5 inch. Okay. So 5 inch variation is happening over, 5 millimeter variation is happening over 5 inch. So 2 millimeter decrease will happen after 2 inch. Okay. So from here I again measure 2 inch. So that will be the point for 10 mm. Like this way, here also we can take the difference and I can see the distance and I can see where it will be 10. I can mark it. So like this way, I mark this, and then I can actually join between A point and D point, okay? And I can no, it is not coming. Okay, anyway, I can have one point here, is not it? You cannot see it anyway. So I draw, okay, this way I can do. Okay, so here I got a 110. Like this way, there are so many joining options are there. Okay, I will join each and every one. So that is what I will get more points. Okay, so I can join here. If you see this 4 to D. So here I will get another 10. I can join here E to D. I can join another 10 here, get. So now all these 10, if I join a smooth curve, then I will get the. So what I will do now, next, I will continue joining. What it happened? No, I have to join this one. So I will continue joining this line by smooth curve. Okay. I don't know. Okay, there may be. Okay, it have done, but I have to change the color. Okay, so this then gives me the ISO height of 10. Okay, now again, as I told, if we do manually, every student will have different. Okay, that is what I will check that you should do on your own, because no two figures should be same. Okay, if you do manually, there is no two human being where all this line will be same. It can be proved. If I give two students, if it is draw, each drawing will be unique, as every human being have unique fingerprint, unique eyes. So if you draw, every drawing will be unique. Okay, so if I see both drawing is same, I will give 0 for that to both of them. I don't care who have done the original, who have copied it. Okay, so that you keep in mind. And for me, it is very easy. If I simply feel it, means see it, and which I have to do, must do before marking, then it will be very obvious. Okay, so you should do it like this way. If I want 8, then I will join 7 to 9.2, 7.2 to 9.24. Okay, so then I will get all the 8 points. So like this way, you can calculate, get the ISO height, and then get the calculate the area between two ISO height by either graphical method. Okay, either by this graphical method or by planimeter, then it will be done. Okay, now I will show here how to, using graphical method, you can actually calculate the area. Okay, suppose let us take this catchment, this Thiessen polygon around station E. Then in order to calculate the area, we know that this is 1 millimeter per 1 millimeter. Okay, in the graph paper, I can actually measure 1 millimeter per 1 millimeter. So 1 square means 1 millimeter square. 1 square millimeter. 1 box means, okay, 1 square means here. So I can actually count what is the total full box. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. So 11 number of total boxes are there. Okay. And then again, as I told, it will come to my accuracy. Now, if we see these two boxes, upper one, I can see, I can understand that no, this will not, this will be more than 1. Okay, but this box and this box, I can assume that total of these two boxes, I can take it as 1 full box. Okay, this box and this box. So this box and this, this box. Okay, this box and this one, this is lower here. This I can take as a 1 box. Okay. So this 2 is over. This one is still remaining. This one is also, this one is over. So this one and this one. So, okay. So this one and this one can be 1. Okay. Now, if you add, means if I, okay, and this one is obviously 1. Okay. Here it is very small portion is there. Here very small portion is outside. Okay. Now this one and this one I can easily, means I by approximate I can tell this is 1.5. So if this is gone, it will be around 1.25. If we add this one and this one, more than that. So if we add this to 1, it will maybe 1. Okay, but this one is over. So these 3, if we add, it may be 2 and maybe 0.25. Okay. So here I am getting some difficulty, but in manually I can actually tick. Okay. My calculation would be easier if I tick this one and I can write. So what is the total now? 11, 12, 13, 14, 15, 11, 12, 13, 14, 15, 16, 18, 18.5. Okay. So that is in my millimeter square. This is in my graph paper. Now I will go to the scale of this map. Okay. If the scale of the map is 1 millimeter is equal to 1 kilometer, then in actually what will be our, suppose in the scale of the map is 1 millimeter equal to 0.5 kilometer. Okay. Then actual ground, what is the area here? Area will become, okay, area will become, what is then 1 millimeter square? 1 millimeter square in the map means 0.5 into 0.5 square kilometer. Okay. So I have 18.5 millimeter square. So area is 18.5 into 0.5 means 0.025 square kilometer. Okay. So like this way, by
Sir, it will be 0.
Sir, 0.25.
Yes, sir.
0.25. Yes. Okay. Sorry. 5 into 5, 25. So 2 decimal, 0.25. Okay. So it will be 0.25. So that is the area. Okay.
4.625.
What?
Multiply.
Yes. What is the value? Ultimate value?
4.625.
4.625. Let
Yes, sir.
let me write
Kilometer square.
4.625 kilometer square. Okay. So this procedure, knowing it, it may be easy, it may be useful to you. Suppose you are in a remote site where nothing is working, okay, but you need some quick calculation for your understanding. That time you can use this crude method for a approximate understanding, because obviously this may not be accurate, okay. But suppose somewhere you are in a meeting, you need to quickly understand what may be the area, okay. That time you can see if place it over a graph paper and quickly you can calculate, okay. So this may be handy, useful, because not always you have GIS with you, okay. And you have to make a guess, calculative guess, that what may be the area. Okay, so a experienced engineer, he gets so much experience that by looking on the area, he may tell around plus minus 20% or 10% what may be the area. Okay, if you work on the same thing 25 years or 10 years, you will have that means capability. So that capability, as I think you should try to develop that kind of capability. You should look that, okay, and you try to tell yourself what may be the distance from this point to this point. In your house, you can see from one wall to another wall, and you can think what may be the distance, and then you can buy one tape which may be 20 rupees or 25 rupees, okay, very low quality, and you can measure it yourself and see what is the actual distance. In this way, if you as a civil engineer, you should have always this capability, your third intuition about this area, distance. It will be useful, okay. So from now on, you can start developing at least eye for the distance, okay. So with this, if any questions are there?
Yes, sir. So in the
Okay.
isoheital method, so can you
Yes.
go back to the slide?
Yes, isoheital method, yes.
Yes, sir. Here we have drawn the 10, the isoheital for 10, right?
Yes.
So, but how, we joined 9.2 to 12, right, sir? And
Yes.
then we looked in between, there will be somewhere 10. But
Yes.
this line can be anywhere, sir, up and down. We can move this 10 line. How we will decide where it will be?
Okay, that is what okay, let me explain again. How we'll decide where is the 10 point, is not it? First
Yes,
of
sir.
all, we are joining by a straight line, okay? And we are, our assumption is that it will be varying linearly, okay? And as we are joining the straight line, that will be the highest variation. The line can be anywhere, as you were told. This I can join by anything like this, okay. What your confusion is like this, but no, for easiness we are considering that we'll assuming the steepest one is always the straight line.
No,
So-
sir, this is not what I was asking.
Okay,
Sir,
okay.
the yellow line that we have drawn, we can move it, right? It can be slightly downwards or slightly upwards. How did we
Yes.
decide that?
There is no way you can decide. That is means that is over you, up to you, okay. But the yellow line should pass, is not it? And it should look smooth. That is the issue. It should look smooth. It should not be looking going up, going down, okay. It should look smooth cut.
Yes,
So,
sir. And secondly, sir,
What
if,
you are telling, let me draw another. This line is also not smooth, what I have drawn. But what your confusion is, I can join these two lines like this way. Is not it the point?
sir, No,
Yes.
sir. The whole 10 line that we have drawn, we can simply move it up and down. We are not changing the curve.
No, what you are, okay, let me draw this. So are you telling that the same line I can draw like this? Because this
No,
is,
no, sir. The curve is the same, sir. But like we can just simply shift it to slightly downwards, the line to downwards.
okay,
Whole line.
okay, I am showing the what you are saying. So instead of this, I can shift here. That is what you
Yes,
are telling.
sir. Yes, sir.
But
Then
how that, no, how that is, then you have not understood. This point, these blue dots I have fixed now. So this line should pass all these blue dots. Okay. And how I have fixed the blue dot, that is what, let me explain that I have joined these two lines. Here it is 12, here it is 9.2. Okay. So what is, now I will measure the distance of this line, length of this line. CD line, I will measure the length. Okay. So suppose the length is 3 mm. So the distance CD is 3 mm. Then what is the variation between C and D? It is 12 here, it is 9.2. So variation is 12 minus 9.2. That is 2.8, is not it?
yes, sir.
So 2.8 rainfall is varying over 3 millimeter. Now here it is 12. I have to get the point where it is 10 in between CD lines. So
I get it, sir. Now I
that
get
means
it.
from here it is 2. Okay.
Yes, sir.
Okay. So you see 2.8 variation is happening over 3. So one variation is happening 3 by 2.8. So 2 mm variation will happen 3 by, it is simple arithmetic, is not it? Into 2.
Yes, sir. Now I get it, sir.
Okay, you tell me the value. Let me actually complete it. 3 by 2.8,
1.07.
1.07. Okay, so from this D point, I will go 1.07. And then I will cross there. That will be
Sir.
one of the point on your ISO height 10. Okay.
Yes, sir. This way we will point out all the points, right, sir?
No, but how?
then-
Why it will be 1.07? It should.
Sir,
It should be more
1.07 into 2, that is
2.14, sir.
2.14.
That is what you tell that, because I can easily see it is around more than 1 and into 2. So it should be more than 2, is not it? So 2.14. Okay. So it is 2.14. Like this way, each and every possible thing will join and will mark it where it can be 10. Then all these point will be joining by smooth curve. Okay. That will give me the 10 isohedral line.
So, sir, somebody can take 11 isohedral line or somebody can take 9 isohedral line.
Yes, somebody can take.
That depends on our
Somebody
interval.
can take 9.5 also, 9.3 also.
So
But
means these methods are not relevant because it changes from person to person. The answer will vary from them. So these should not be considered relevant too.
Yes, sir. And the rain cannot be linear, right, sir? I mean, it's decreasing down the,
yes,
map.
yes, that are the disadvantages. Okay. But it is relevant. It is not that we cannot use it. Okay. We can use it. Then means that is what some guidelines are there, that you have to use this means inter-isohytal area should be at least 1 mm. Then our code will give me some guideline to use this method. But it is true what you people have telling me that you can take 9, somebody can 9.5. So the answer may be different for different person. But that does not mean that we cannot use this method. We can say that accuracy is less. Okay. It is not 100% reliable method. But the problem is, what is the reliability of rainfall, or all the things related to rainfall, how much it is reliable? Rainfall itself is a problematic phenomena, is not it?
Yes, sir.
You know that still now human beings have done so many things, but we cannot measure rainfall properly, or we cannot predict rainfall, or we don't have much knowledge about the rainfall mechanism, cloud physics. There we cannot go beyond. Somewhere we cannot understand how rain is forming, and how much rain in the same cloud, how much rain will fall. It is very difficult. Okay, the thing is purely random somewhere. So all these things in hydrology, you have must learn that most of the things are not 100% accurate. Okay. But let me ask you, then what you will do? Because I need it. I need to do it. So what is my aim? We need to find out the highest, means least problematic method or least erroneous method. Whatever we can do, we will do to improve it. But it is not possible to get highly accurate. Okay, so whatever your doubt is, then what is the way to satisfy everybody? I can satisfy everybody if we have 100 rainfall measurement within this point. Okay, I have so many rainfall station that I have here 10.2, 10.3, 10. So then I can have actually exact value in between where it is 10. I don't have to draw a straight line. Because I have the data already. Okay, but where you know how much cost it will be to install a rain gauge station, and how means to collect the data, is not it? So it is not possible. We can increasing accuracy means more data here. Is
Sir,
it clear? Yes.
in practical way, how many rain gauge stations are installed at particular distance?
Okay, means there is guidelines are there. Let me check and I tell you. Okay, I think you should have written in the thing. That is guideline again, but here it is given. Okay, as per World Meteorological Organization recommends the following densities. In flat region of temperate Mediterranean and tropical zone, ideal is one station for 600 to 900 square kilometer. That means 30 kilometer by 30 kilometer area. In mountainous region, the area requirement is lower, because in mountain the variation is high. Okay, so it is given And but from practical consideration, it is worldwide. Indian scenario, it is given in plain 1 station per 520 square kilometer. In region, average elevation of 1 kilometer, 1 station per 260 to 390 square kilometer. And where rainfall is heavy, 1 station per 130 square kilometer. This is the guideline, but I can assure you we have more than this. Okay, our rain gauge station is very much stronger, because nowadays we have, I think it is mandate is there in BDO office, in Gram Panchayat office also. It is supposed to be one rain gauge measurement station. Okay. So, but it is problematic. Not all the data are collected, but at least in district headquarter and IMD stations, other university colleges, they have. Okay, so we have actually more than this rain gauge station, but collecting the data is problematic. Okay.
Yes, sir.
Okay. So can I move to? I think it is okay, but still I will show some YouTube videos. Then, as I told, what about? I saw one notice that you are coming. Third, your notice have not yet come, na? Fourth semester hostel for coming back to the hostel. When are you coming back?
Sir, no notice, sir. Only willing can come.
Yes.
Sir, those who want to come, they can come, sir. Classes will
can
run online.
Okay, classes will run also. What I am thinking that means when some of you will come, so I will take help of you, and then I will take some video. Okay, or now you can come. So maybe Rudrodeep and from your section 1-2 student I will call, and then we'll do the experiment. Okay, then I will take the video and I will show it online to others. Okay, I think some of that I will do after the mid semester. Okay, in 1 or 2 days I will film all the videos. Okay, that was I was thinking after I got the notice. That will be a good option. So anyway, let us see videos of another professor of this North Carolina School of Science and Mathematics. It will be okay. Let us go. It is of 12, 17, 21, 25, half an hour. Okay. I think it may not be required because some of you have understood very clearly, but still I am undecided what to do. What do you think? I will show the video or not? Because I am happy today that the student who needs to be understand, they have understood already. I ask someone. Okay, somebody tell something, not a issue.
Sir, you can share the link in the classroom.
Okay, then you will see it later, is not it?
Yes, sir.
Okay, that will be good. Okay, then if any questions are there, ask. Otherwise, we'll move to the QGIS. Okay, so manual part is over. So manually, I hope that you have learned how to delineate a catchment, how to measure the area in a planimeter, and then how to calculate average rainfall over a catchment from the point rainfall values. Okay, using arithmetic mean method is not a method at all. Using your Thiessen polygon method and isohydral method. Okay, so we will, if no questions from manual part, we'll go to QGIS part. Okay. So for your case, I think it is better to start from the beginning of the catchment delineation. Okay. Or you have remembered or forgotten. Okay, anyway, I leave it to our madam. Okay, so Songita.
Yeah.
Okay, you can start now.
Okay. So students, in last class we completed till the field sinks. So all of